on the amplitude, the period, and the phase shift, and sketch the graph of the equation y equals sine of 1/2 x minus pi over 3. Well, we know that for a curve of the form y equals a sine of bx plus c, the amplitude is the absolute value of a. In this case, that's the absolute value of 1, which is just 1. So the amplitude is 1, and the curve will go up and down to a maximum of plus or minus 1. The period is found by computing 2 pi divided by the absolute value of the b term. B is 1/2 here, so 2 pi divided by 1/2 is 4 pi, and the period of this curve will be 4 pi. The phase shift can be found by computing we can do the opposite of c divided by b. In this case, c is negative pi over 3, so the opposite of that is positive pi over 3. And we divide by the b of 1/2 that we noted earlier. Multiplying by the reciprocal gives me 2 pi over 3 for the phase shift. Now, if you're going to sketch the graph, it's often helpful to work with the interval from 0 to 2 pi for the argument of the sine function. So 1/2 x minus pi over 3 between 0 and 2 pi gives me one full cycle of the sine curve. If I solve for x in this inequality, I can determine the range of x that will produce one full cycle. The length of that cycle should be 4 pi units, but we can actually find which values of x produce that cycle. So we'll add pi over 3 to both sides, or all sides. And 2 pi plus pi over 3, well, 2 pi is 6 pi over 3, and another one gives me 7 pi over 3 altogether. Multiply everything by 2, and we have 2 pi over 3 is less than or equal to x, which is less than or equal to 14 pi over 3. Notice that the distance from 2 pi over 3 to 14 pi over 3 is 12 pi over 3. That's precisely the 4 pi that we had for the period. Now to sketch the graph, we're going to have a fairly wide swath of values on the x-axis. Clean that up a bit. So that we can go for a full cycle, which is going to be 4 pi units wide, and it's going to range from 2 pi over 3 to 14 pi over 3. So I'll mark intervals of 2 pi over 3 on my axis. There's 2 pi over 3, 4 pi over 3, 6 pi over 3 is going to be 2 pi. And there's 8 pi over 3, 10 pi over 3, 12 pi over 3, that's the 4 pi, and 14 pi over 3 is where my cycle is going to stop. Now the first cycle for a sine curve, any cycle for a sine curve starts at 0 and ends at 0, and it is 0 halfway in between. This was 6 pi over 3, so this was our 8 pi over 3 mark. Remember, the sine curve's basic cycle starts at the origin and ends at 2 pi comma 0, with a value of 0 also at pi in between if you're looking at an unshifted sine curve. Let's see, from there we can work out the maximum and the minimum to be plus or minus 1, since we have an amplitude of 1, and that maximum will occur halfway between the roots here. If we average 8 pi over 3 and 2 pi over 3, we have 10 pi over 3 divided by 2, that's 5 pi over 3. And so this was 4 pi over 3 and 6 pi over 3, so 5 pi over 3 is halfway in between. That's going to give us the value for the maximum of this curve, 5 pi over 3. And likewise, halfway in between 8 pi over 3 and 14 pi over 3 will be 11 pi over 3. And that's going to give us the location of the minimum for this curve, and we can fill in the gaps now by just connecting the dots and tracing out a sinusoidal shape. Now I'm going to leave it there since I'm running out of time, and you can shift this curve to the left and to the right to form the entire sine curve, or at least other cycles of the sine curve, by just adding or subtracting the period 4 pi to each of the points that we've identified already.